Hey everyone, this is Carter with First Updates Now. I'm here at the Michigan State Championship with Team 85 built on brains. They have an under the bumper intake, pivoting shooter, and a beautiful climber. We'll check all about this and more on this episode of Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
All right, Bryce, can you tell me a little bit about your intake to start?
Yeah, so from the beginning of the season, we really wanted to be a touch it, own it team. So we decided to do an offset swerve drive, so where our swerve drives are slightly in from our frame perimeter. And then from there, it allows us to have our entire length of the booster bar. Yeah, Josh, you want to pick up? So yeah, you see we got some stealth wheels right here, and we have these funnel guides right here. So anywhere a note comes here, the note will pivot around and go straight up into this roller and these sushi wheels in the back.
Beautiful. Can you tell me a little bit about different iterations you made with those rollers down there and different compressions?
Yeah, so from the beginning of the season, we knew that having really good grip on the notes is going to be important. So we iterated with different types of materials to actually grip and pull the note up into our robot. So we actually use this is like carpet tape. So like on the underside of carpet, the tape that you use to stick down the carpet to the floor, that's the kind of tape we use. And we found a lot of success with that.
Awesome. I really like that unique idea. Now, Josh, can we move on to the transfer system, the pivot, and the shooter?
Yeah, sure. So we have this pivot. We're able to have a very wide range of adjustment here. We are enabled, so it's not going to move that well. But we're able to move this all the way around. Gibson, maybe you can demonstrate that for us right now. But we're able to intake, and the note's going to be able to go in at any angle that's over here. And then this is going to be our amp shooting position up over here. We'll be able to demonstrate how this goes in right now. So as you can see, it goes in very easily on that angle, and this is going to be our amp shooting position. So we have this wheel here and these wheels, as well as these polycarbonate guides that are really going to help when it hits up here, the note for the amp shooting, then it's going to help guide that right in, and it's worked very well for us. And then we can pivot it over to the other side, and that's going to be our speaker shooting side is primarily going to be on this side. So we have our limelight and our auto targeting algorithm, and that is going to use these wheels here. It comes up into here. We have some static rollers here that give the note a little bit of sideways compression, and we found through our prototyping process that is actually our way to gain a little bit of accuracy out of it. So these compliant wheels here will help guide it up in there. Whenever our shooter wheels have reached desired RPM, then we're going to shoot that out into the speaker.
Awesome, and I see a couple of belts down there. Can you tell me a little bit about the different iterations you have gone through with different rollers? Have you always had those belts there and things like that?
Right, so we originally started with probably about half of the compliant wheels that are on both of these shafts here. And we just found that we needed to have a little bit more grip, because when the note gets up here and it gets compressed, we were starting to lose grip kind of on the outside of that, as well as when the shooter is at a different angle, sometimes it wants to grab in different spots. So those orange belts and the additional compliant wheels help us keep a good grip on that note.
And last thing on this topic, I'm curious about this little green stealth wheel here. Is there a reason for that, and was that always there?
Absolutely, that was added after our second competition. We found that every once in a while, we would lose grip on the note when we were shooting into the amp, and just adding that little wheel in the center was able to help us keep our amp shooting more consistent.
Awesome. I love the note mechanism here. And Nathan, can we move on to our climber mechanism that we have here? I see you have a custom gearbox down here. Tell me a little bit about that.
Yeah, for sure. So we went for a very small base for our climber because we don't have a lot of space left on our robot. So we moved the motor up into the air with a worm gear coupling. So that gives us loads of mechanical advantage. So when we climb and we're above the ground and our power goes off, that mechanical advantage is going to keep us in the air, so we won't slide down at all. This has actually gone through a few iterations of its own. We changed this gearbox from a 5-to-1 to a 3-to-1 just to get a bit faster climb up and down. We also have these hooks up here. They were originally double-sided, more of a pickaxe look to them, but we can only climb on one side, so we switched it to this 3-tooth design just to get as much possibility of hooking on that chain as we could. These polycarb sheets here just to keep notes off as best we can.
Awesome. I love the climber. Very unique. All right, and then last thing that I have here when it comes to mechanical side of things is tell me a little bit about your drivetrain. What are you running in what gear ratio?
We are running a just generic swerve drive from Swerve Drive Specialties. This year we moved from an L1 gear ratio to a L3 to get more speed in. We also offset them from the side, as Josh said before, just to get that booster bar, as much intake as we can. There isn't a whole lot more to it.
And can I actually see a demonstration of this climber?
Yeah, for sure. Gibson. So that's just our generic center beam, right? And then we can bump these up each side higher a little bit for harmonizing with our opponents or our alliance partners. Very maneuverable.
Awesome. I love it. And Gibson, can we now move on to the software side of things? Tell me about some of the sensors, cameras, LEDs that you have on the robot.
Yeah, so at the beginning of the season, we had lots of problems with our notes intaking too far and actually contacting these wheels, and we just couldn't shoot far enough. So we added 2 through beam sensors right here on the side. And what this allows us to do is check where the note is in our indexer. So if we see that the note is up here, we will actually reverse the indexer so that it won't be contacting the shooter wheels. We also have 2 cameras right now on our robot. We have our targeting camera, and this is mostly just used as a driver cam, and when we intake a note, it will flash the lights on it. Auto targeting this year, we took a different approach as most teams do for auto targeting. We're using a quadratic regression. So basically, we have this tool that we can watch drive practice, and every single time we shoot, it will log the height of the April tag on the speaker and our pivot angle. And what this allows us to do is press if it was too high, too low, or if it went in, and if it went in, it'll automatically add it to our points so our regression can be as accurate as possible.
Awesome. Mechanically beautiful robot. I love how simple it is, and software-wise looks very successful. You guys have had a phenomenal performance so far, and good luck the rest of this weekend for you guys. This is Carter with First Updates Now, signing out.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.